Okay, let's get right into it. When we talk about NVIDIA's latest announcements, you might think it's all just about faster chips. But it's so much bigger than that. What we're really looking at here is the blueprint for a whole new industrial revolution, all powered by a completely new kind of AI. And it all starts with this one idea. This is the key. We have to stop thinking about AI as just another app on our computer, like a spreadsheet or a word processor. The huge difference here is that AI isn't just a tool for us to do work with. It's becoming a workforce that can actually do the work itself. And once you really get that, it changes absolutely everything. So if AI is this new kind of worker, that brings up a really important question, right? Where do you build this workforce? Every worker needs a place to work. And for AI, that means a factory. But we're not talking about a factory with smokestacks and assembly lines. We're talking about something totally new. And that, right there, brings us to the core concept of this whole thing, the AI factory. This is NVIDIA's big vision. It's the infrastructure that's going to generate this new AI workforce. This is a brand new type of computer system, and it's built for one singular, incredible purpose.
Its one job is to produce intelligence. And it produces that intelligence in the form of what are called tokens. You can think of tokens as the basic building blocks of AI. Just like words are the building blocks of language, tokens can be words, they can be pixels in a picture, or they could even represent a robot's next move. This factory's only goal is to churn out these intelligent building blocks as cheaply and as efficiently as it possibly can.
This really makes the difference super clear. A traditional data center is kind of like a jack of all trades. It stores your photos, it runs all your apps, it serves millions of different users doing millions of different things. But the AI factory, it's a specialist. It has one mission and one mission only, to generate valuable, intelligent tokens and to do it at a massive scale. It's not storing data, it's literally manufacturing intelligence.
But here's where we hit a snag. We've kind of hit a wall. There are these two huge exponential forces that are demanding more and more AI power. First, the AI models are getting smarter and bigger. And second, as they get smarter, way more people want to use them. It's this amazing upward spiral of demand, but it's happening at the exact moment that Moore's law, that old rule about computers doubling in power every couple years, has pretty much died. So the big question is, how do you feed an exponential hunger with just linear growth? Well, that's the answer. Not a small, little improvement, a 10 times generational leap in performance. This is the kind of massive breakthrough you need to keep that AI flywheel spinning, and what makes it possible is the new Blackwell architecture, which is basically the engine at the very heart of these new AI factories. You just don't get a 10x jump by making a slightly faster chip. It comes from this strategy they call extreme co-design, and that means you basically tear up all the old blueprints and you re-architect everything, all at the same time. The chips, the systems, the networking, the software, all of it is designed from the ground up to work together as one single colossal computer. Okay, so we've got these incredibly powerful AI factories pumping out intelligence. But what's it for? What's the point? This is where the story takes a huge pivot, from the digital world we've been talking about to the physical one we live in. We're now talking about an AI that doesn't just understand language, but one that understands reality itself. We are talking about physical AI. This is a whole different class of AI that is grounded in the real world. It gets that if you drop something, gravity makes it fall. It understands cause and effect. And this is the absolute key that unlocks AI's ability to move beyond our screens and start operating skillfully and safely out here in our world. And creating this physical AI is this really fascinating three-step process. First, you train the basic model on a huge AI supercomputer. But then, and this is the magic part, you put that AI into a perfect physics-based digital twin of the real world so it can practice. It can run through millions of scenarios without ever breaking a single real thing. And finally, once it has mastered the virtual world, you deploy that intelligence into a physical robot. And look, this isn't science fiction anymore. It's happening right now. We're seeing it in humanoid robots and factories. We're seeing it in surgical robots that can perform procedures with superhuman precision. And of course, in the next wave of self-driving cars. Even Disney is using this stuff to teach its characters how to interact with the real world. It's incredible. So we have AI factories building digital intelligence, which then powers robotic factories that build physical things. But hang on, how do you build those incredibly complex physical factories in the first place? Well, you actually follow the exact same logic. You build a blueprint in the digital world first.
Now, this idea is a little bit of a mind-bender, but it's just so powerful. The idea is, before you pour a single yard of concrete for a new manufacturing plant, you build the entire thing down to the last nut and bolt as a perfect digital twin. You build a virtual factory to perfect your real one. Using this digital twin lets you optimize everything like never before. You can perfect the factory layout. You can train your whole fleet of robots so they're ready to go on day one. You can even co-design the building and its cooling systems to perfectly match the AI hardware it's going to house. And the result? You shrink the time it takes to get these massive facilities online by a huge amount.
And all this high-tech simulation and digital planning, it all leads to a very powerful, very real-world outcome. It's what's enabling a whole new era of advanced manufacturing, and it's bringing complex production back to places like the United States.
And the speed here is just astonishing. I mean, this isn't some 10-year plan. From the time the commitment was made to bring manufacturing back, it took just 9 months to get the new Blackwell chips, the engines of this whole revolution, into full production. That kind of speed is only possible when you take a digital-first approach.
So let's just pull this all together for a second. We've gone from thinking about AI as a simple tool to seeing it as a workforce. We've seen the rise of a new kind of factory, the AI factory, designed to produce intelligence. And we've seen how that intelligence is now crossing the border from the digital world into our physical one, enabling a whole new generation of robots and factories. This isn't some prediction about the future. The revolution is happening right now.
And that leaves us with one last really fascinating question to think about. For all of human history, learning has been this slow, risky process of trial and error in the real world. But now we have robots and AIs that can get a lifetime of experience in a perfectly safe simulated world before they even take a single step in ours. When that's the new reality, what new frontiers truly become possible?